Dear junior JEEIT students, we are handling the topic trigonometry in mathematics 1A. Exercise 6C chapter is going on. Page number 259. Roman number 3. In previous class I said Roman number 2, not Roman number 3. Roman number 2, general number 2, 3 sums completed. First and second I given homework already. Third question I said. Now fourth question. Sin of alpha plus beta by sin of alpha minus beta is equal to a plus b by a minus b. Prove that a tan beta is equal to b tan alpha. This is also objective question. Before going to discuss about this sum, we need to learn the concept componendo and dividendo. Componendo and dividendo. If a by b is equal to c by d. If the two fractions are equal, that is a by b is equal to c by d, that implies a plus b by a minus b is equal to c plus d by c minus d. That's all. So numerator by denominator is equal to numerator by denominator of two fractions. So summation of numerator and denominator by difference of numerator and denominator of first ratio is equal to summation of numerator and denominator and a summation of numerator and denominator of second ratio. That's all. The concept is called as componendo and dividendo. The concept is called as componendo and dividendo. Componendo and dividendo. The concept is componendo dividendo. Now, depends upon given question. Given sin of alpha plus beta by sin of alpha minus beta is equal to a plus b by a minus b. This is given condition. Now apply componendo comma dividendo. Apply componendo comma dividendo. That implies, now take the componendo concept for left hand side and also right hand side. So right here sin of alpha plus beta plus sin of alpha minus beta whole by sin of alpha plus beta minus sin of alpha minus beta is equal to a plus b plus a minus b whole by a plus b minus a plus b, because this is minus of a minus b within the bracket. So that implies the formula is that the transformations sin a plus b plus sin a minus b becomes 2 sin a cos b. That implies you can write here 2 sin alpha cos beta. 2 sin alpha cos beta whole by sin of a plus b minus sin of a minus b formula 2 cos a sin b. So now we can write 2 cos alpha sin beta is equal to, here b and b get cancelled, a and a get cancelled. So write here 2a by 2b. This 2 and this 2, this 2 and this 2 get cancelled. That implies sin alpha by cos alpha you can write as tan alpha. Tan alpha into cos beta by sin beta becomes cot beta is equal to a by b. That implies, now we can write tan alpha by tan beta, because cot beta gives the value 1 by tan beta. Tan alpha by tan beta is equal to, this is A by B. Taking cross multiplication, we can get here A tan beta is equal to B tan alpha. That's all. Same question is there in objective compound tangents topic level 3 first bit. This is the proof of the question. Now we have completed Roman number 2 questions, page number 215 and exercise 6C. Let us going to discuss about Roman number 3 in the same page, same exercise. Roman number 3. First one. If a minus b is equal to 3 pi by 4, show that 1 minus tan a into 1 plus tan b is equal to 2. Given a minus b is equal to 3 pi by 4, so applying tan both sides, applying tan on both sides, that implies tan of a minus b is equal to tan 3 pi by 4. Here tan 3 pi by 4 meaning tan of 135 degrees. Tan of 135 can be written as tan of 180 minus 45 or 90 plus 45. So you can write tan 180 minus theta minus tan theta second quadrant. In the case of 180, name will not be changed. So tan 45, here tan 180 minus 45 becomes minus tan 45, minus tan 45 value here minus 1. That implies tan of a minus b formula, tan a minus tan b by 1 plus tan a tan b, tan a minus tan b by 1 plus tan a tan b is equal to minus 1 by 1, right? And taking cross multiplication, we can write here tan a minus tan b is equal to minus 1 into 1 plus tan a tan b. So minus 1 minus tan a tan b. Minus 1 minus tan a tan b. This minus 1 taken this side and these terms taken this side. Minus 1 taken left side becomes only 1. So 1 is equal to, write like this, tan a. This is minus tan a. So minus tan a I am writing, minus tan a plus tan b, minus tan a plus tan b minus tan a tan b. Now add 1 both sides. Adding 1 both sides, that implies 1 plus 1 becomes 2. 2 is equal to 1 minus tan a, put a group here, plus tan b minus tan a tan b. Simply we added 1 both sides. That implies 2 is equal to 1 minus tan a minus tan b taken common. Within the brackets it becomes, this is minus 1 minus tan. Whenever tan b taken common, we can put here. Okay, plus tan b taken common, we can write here 1 minus tan. During 1 minus tan A, we can take common 1 minus tan A. According to question, now we can write here 1 minus tan A taken common, 1 minus tan A into 1 plus tan B is equal to 2. This is RHS. Next, third Roman. In the first one only, second question. 3 questions are there. If A plus B plus C is equal to pi by 2, if A plus B plus C is equal to pi by 2, and if none of A comma B comma C, none of A, B, C is an odd multiple of pi by 2, odd multiple of pi by 2. So that meaning is A is not odd multiple of pi by 2, B is not odd multiple of pi by 2, C is not odd multiple of pi by 2. Why he is mentioning it is not odd multiple of pi by 2 with us? Meaning tan 90 is equal to infinity. Tan 1 into 90, 3 into 90 like that. Otherwise cos 90 equal to 0 like that. So 0 and infinity terms should not be to prove the given concept. That is why he given that A, B, C are not odd multiple of pi by 2. Then prove that first one, cot A plus cot B plus cot C, cot A plus cot B plus cot C is equal to cot A, cot B, cot C. Second one, tan A, tan B plus tan B, tan C, tan A, tan B plus tan C, tan B, tan C plus tan C, tan A is equal to 1, and hence deduce that using this one we need to prove, and hence deduce that sigma cos of A plus B, no, cos of B plus C, cos of B plus C by cos B cos C is equal to 2. Take first one, given A plus B plus C is equal to pi by 2. A plus B plus C is equal to pi by 2. None of A, B, C is odd multiple of pi by 2, it's okay. That implies A plus B is equal to pi by 2 minus C. Pi by 2 minus C. Here apply cot both sides. Apply cot both sides. That implies cot of A plus B is equal to cot of 90 minus C. Pi by 2 means 90. That implies cot of A plus B formula cot B cot A minus 1 by cot B plus cot A. Cot B cot A minus 1 by cot B plus cot A is equal to cot 90 minus C becomes tan C. That implies, write the formula cot B cot A minus 1 whole by cot B plus cot A. cot B cot A minus 1 by cot B plus cot A is equal to 1 by cot C. Take cross multiplication. So cot C into cot A cot B minus 1 is equal to cot B plus cot A. That implies multiply cot C, cot A, cot B minus cot C is equal to cot B plus cot A. That implies cot A plus cot B plus cot C, cot A plus cot B plus cot C is equal to cot A into cot B into cot C. This is first proof. Next proof, tan A tan B plus tan B tan C plus tan C tan A equal to 1. Second one, take the value given A plus B plus C is equal to 90 degrees. That is pi by 2. So in the similar way, Z taken this side, A plus B is equal to 90 minus C, we can write. A plus B is equal to 90 minus C, and applying tan both sides. That implies tan of A plus B is equal to tan of 90 minus C. Tan of A plus B formula, tan A plus tan B by 1 minus tan A tan B. Tan A plus tan B by 1 minus tan A tan B is equal to tan 180 minus C formula cot C. That implies right here tan A plus tan B by 1 minus tan A tan B is equal to 1 by tan C. Taking cross multiplication, tan C into tan A plus tan B, tan C into tan A plus tan B is equal to 1 minus tan A tan B. 1 minus tan A into tan B, that implies multiply with tan C. So it is tan C tan A plus tan C tan B is equal to 1 minus tan A tan B. 1 minus tan A tan B. So that is this one taken this side and write it in the order. That implies, therefore I am writing, therefore tan A tan B plus tan B tan C plus tan C tan A tan B plus tan B tan C plus tan C tan A is equal to 1. Put a box here and put a star mark here. This is useful. Directly I write these formula in objective, or you can write sigma tan A into tan B is equal to 1. Sigma tan A into tan B is equal to 1. Put Ramanavram, that is an equation of 1. Using this one, you have to deduce the question. This one sigma cos of A plus C by cos B cos C is equal to 2. Now, this question. Now sigma cos of B plus C. Sigma cos of B plus C by cos B cos C. sigma cos of b plus c by cos b cos c. Expand this one, cos of b plus c formula, cos b cos c, cos b cos c minus sin b sin c, cos b cos c minus sin a sin b sin c by cos b cos c. That is equal to separate, write separately, cos b cos c by cos b cos c minus sin b sin c by sin b cos b cos c. This is get cancelled. You can write sigma 1. Sigma 1 minus, this is sigma tan A tan B. Sigma 1 minus sigma tan A tan B. I said here sigma tan A tan B is equal to 1. Sigma 1 means you can write 1 plus 1 because it is trigonometry. Angles, 3 angles are there, 3 sides are there, 3 vertices are there. So whenever sigma 1 is there, you need to write the sigma 3 times. So 1 plus 1 minus sigma tan A tan B. 1 plus 1 minus sigma tan A tan B. From 1, I mean from Roman number 1, the equation what we thought we can write, instead of sigma tan A tan B is 1. So it is 3 minus 1. The answer is 2. These are fundamental basic sums. So somewhat depth. Then this you will be facing objective. That is only level 1. Level 2 is somewhat different. Level 3 is more different. Like that, you are going to face objective very soon. Roman number 3, page 259, Roman number 3, second one, first question, 2 questions are there. So this is the last question of this exercise. Prove that sin square alpha plus cos square of alpha plus beta plus 2 sin alpha sin beta into cos of alpha plus beta is independent of alpha. Is independent of alpha. Sin square alpha plus cos square of alpha plus beta plus 2 sin alpha sin beta into cos of alpha plus beta is independent of alpha. So if you are multiplying, I mean if you are expanding the answer, you will not get the value in terms of alpha. In terms of beta, okay, let it be no problem. But alpha you should not get the value. That is why if you get like this, you can say that it is independent of alpha. Sin square of alpha plus, here take common, cos of alpha plus beta. Here cos square is there, here simple cos term is there. So take cos of alpha plus beta common. So here you can write cos of alpha plus beta plus 2 sin alpha sin beta. 2 sin alpha sin beta. You remember the formula 2 sin A sin B. I said the transformations today. 2 sin A sin B formula cos of A minus B minus cos of A plus B. Cos of A minus B minus cos of A plus B. that is equal to, right here, sin square alpha plus cos of alpha plus beta into cos of alpha plus beta plus, write this formula, 2 sin A sin B is equal to cos of A plus B minus cos of A minus B. So you can write here 2 sin alpha sin beta is equal to cos of alpha plus beta plus cos of alpha plus beta into cos of alpha minus beta into cos of alpha plus beta. So cos of alpha plus beta get cancelled. That is equal to sin square alpha plus cos of alpha plus beta into cos of alpha minus beta we got. Before going to discuss exercise 6a topic, I said the formula cos of A plus B into cos of A minus B is equal to cos of A plus B into cos of A minus B is equal to cos square A minus sin square B. This is a formula. That is equal to here sin square alpha plus, right here, cos square alpha minus sin square beta. Using the identity sin square alpha plus cos square alpha becomes 1. So it is 1 minus sin square beta. 1 minus sin square beta becomes simply cos square beta. Whatever he said, independent of alpha. We did not get alpha. So we can say that this is independent of alpha. This is independent of alpha. In the similar way, another question is there. In this question, second one, prove that cos square of alpha minus beta, cos square of alpha minus beta plus cos square beta minus 2 cos of alpha minus beta into cos alpha cos beta. Cos square of alpha minus beta plus cos square beta minus 2 cos of alpha minus beta into cos alpha cos beta is independent of beta. That is equal to, right here, cos square of alpha minus beta plus cos square beta. What is the common here? Here cos square alpha minus beta, here cos of alpha minus beta. Take cos of alpha minus beta common. Take cos of alpha minus beta as a common. That is equal to taking cos of alpha minus beta common. Here you can write cos of alpha minus beta. Leave it, I will say next. Minus 2 cos alpha cos beta. And separately cos square beta you write. That is equal to next step. Let us remember the formula 2 cos A cos B is equal to cos of A plus B plus cos of A minus B. Two cos A cos B formula, cos of A plus B plus cos of A minus B. Now let us write that cos of alpha minus beta, cos of alpha minus beta into cos of alpha minus beta. I think it is not visible. Here I write cos of alpha minus beta into cos of alpha minus beta minus of, write the formula 2 cos A cos B, that is cos A plus B plus cos A minus B. So cos of alpha plus beta plus cos of alpha minus beta within the brackets plus cos square beta separate. That is equal to cos of alpha minus beta. I have taken common. So it is cos of alpha minus beta minus. We expand this one cos of alpha plus beta minus cos of alpha minus beta. This is plus cos square beta. Cos of alpha minus beta get cancelled. That is equal to, now we got minus this cos of alpha minus beta plus, maybe might have taken common. This is plus, no, plus, this we should get cancelled, minus. Plus we should not get cancelled. So that is equal to, now cos of, write like this. Cos of alpha minus beta into cos of alpha plus beta plus cos square beta. That is equal to, here only we have written cos a plus b to cos a minus b formula, cos square a minus sin square b. So you can write here, this is minus cos square alpha minus of cos square alpha minus sin square beta plus cos square beta here. That is equal to, this is minus cos square alpha minus of minus becomes plus sin square beta plus cos square beta. So here sin square beta plus cos square beta gives 1. So this is minus cos square alpha plus 1. That is equal to, you can write here 1 minus cos square alpha. It is nothing but sin square alpha. In this question, what is asking? Prove that it is independent of beta. We did not get the value beta. Therefore, you can write this is independent of beta. This is independent of beta. So here, with this question, we have successfully completed page number 259, exercise 6C, Roman number 3. Students, each and every example, each and every sum in exercise 6C, exercise 6B, exercise 6A, with the theory and concept, everything I said. Now, exercise 6C concept completed, that is compound angles topic completed. Now, we have to face the multiple angles and 3A formula are there. Multiple submultiple angles concept I said previously. Regarding 3A formula, I should discuss with you proofs and everything. Okay students, let us going to discuss about 3A formula in next class.